Let's begin with numbers, and as we proceed, we will try to understand what are these natural numbers, whole numbers, integers, and real numbers. This we will take it through a evolutionary, partially cooked up story, so that there will be a flow as well as we can keep it in memory. To begin with, let's say human beings started domesticating animals, and animal could be anything. Say, if I say a hen or a goat or a buffalo or an ox, you might construe whatever depending on the language which you are used to, or sometimes you might have seen. Instead, what I do is I generalize. Let's say this is the ground, and there are some 1, 2, 3, 4, something. Okay. I say, okay, this one is one which represents a goat or a hen or whatever you want, you can imagine. Now, imagine like this person takes these things because food is not available. Let's say this person takes all of these things into a forest which is there. Forest or like, yeah, green pasture in the morning, goes for grazing, and then comes back in the evening. This human being will be interested in knowing whether what was taken out in the morning has come back or not. So as long as there is counts like these, it's very, very easy to count, even without having any symbols or numbers. In fact, I read in one fiction novel, very interesting, saying that there is a tribal community which has numbers 1, 2, and anything beyond 2 is many. So very, very simple mathematical system. Okay, but we are advanced, evolved species, so how the evolution happens? Let's assume now, after a few months or years, this count increases. So the same phenomena, like take it to the for grazing and then come back. Now this person wants to understand whether all of them who went out have come back or not. So what is the simple way that they can do is, whenever one of them goes out, maybe take a pebble or stone or whatever and put it there, then maybe take the next one, take the next one, take the next one, like that. So this is the first counting process when there were no numbers, symbols like 1, 2, 3, 4, as we know of now. These symbols didn't exist. So that's the time period to which we have to go. Only then we will be able to appreciate this. So in the evening, when these people return, or like when these things return back, they remove one after the other. And when none of the pebbles are there, which means whatever went out has come in. A very, very simple way. And we can imagine there is a fence which is there, which is enclosing it. This one is the first simple way where people started counting. Numbers basically are used for counting. As this now traverses a little further, let's say another 200 years or 100 years, this quantity would have increased, and using the pebbles would have been difficult, and these would be of different sizes, and that has to be carried wherever they move. So the next easier thing was like maybe start drawing lines on a rock or a soil or wherever. So you can keep drawing lines like this, and then once they return back, you can start doing this. So if all of them match, everybody has come back, or there can be a balance. So this is a very simple way of understanding. One important thing which I want to draw your attention is this improvement of converting from this pebbles or stones or whatever small pieces into lines was a incremental improvement. The same act, but that was simplified. This is one thing which I want to emphasize. Now, with this method, the pebbles are thrown away. Wherever you go, you get some charcoal or whatever piece you have, you can do marking. But now, one more problem surfaces. What is that problem? If I ask you to count all of these things which are there, and a single glance, it will become difficult to say how many are there. From this incremental innovation, you could appreciate, let me draw a similar thing. Instead of crossing every line, this is the next incremental jump. Let's say I combine like this. Now we can quickly say this. 3 instances, so I can say 15. So this becomes very much easier. So again, the incremental, starting with pebbles, lines become complicated when quantities improve. With the same thing, just grouping helps people to understand things faster. From here onwards, it's only simple lines. So we can appreciate some community coming and saying, so this comes into the regime of Roman numerals. Here again, extending from the single vertical line and horizontal line, people started putting, this means 1, 2, 3, very simple, intervals of 1, and introducing a symbol for 5. If there is a 1 before, then you call it as 4. So subtraction comes in. The symbol after 5, which means addition, comes in. So this represents 4 and this represents 6. Then 7, 8, one more symbol for 10, 10 minus 1, 9, 10 plus 1, 11, and it can go on only with these 3 symbols. But this again, though it looks very simple, it was used for quite some time. This again becomes complex. Say if I put something like this, it takes a lot of time to understand and decipher what is the count of that one. Okay. So from here is where we get this number system which has evolved. Counting numbers 1, 2, 3, 4 with the fingers, which you can do. So this is the symbols which all of us right now are very comfortable with which we play around. So these numbers 1, 2 to 9 and of course 10 fingers. So this set of numbers is what we call it as natural numbers. Okay. So we have been going through the evolution just to come up and say how many years or how long it would have taken for a human species to start coming up with simple symbols. Writing it vertically will mean something, writing it horizontally will mean something else. Here if I write, I'll call it as 1, 2, 3, but if I write it here, I'll read it as 123. Okay. This itself is symbolization as well as presentation. Though the numbers are same, they have a totally different meaning. So all that we have to do is to understand the way mathematics plays around using symbols. Okay. Now moving on to the next step. So far we have been discussing all that existed. So the next beautiful step would be how to say there is nothing there. Okay. Counting is like we already arrived at these symbols or one of the symbols we can use to count. One beautiful shift to say nothing is wipe all of these things clear and shrink this symbol like this boundary symbol, which might have been the way the whole thing had evolved, and we call it as 0. So this symbol will represent nothing in math. one important thing which also happened even before these counting numbers came would be relational operators. We call it as relational operators. The equal to, less than, greater than, which can be also said not equal to. So how did this counting thing start? Whatever went out were equal to whatever came back or not. So that's when equal to is required. If something is less, then I need a symbol for that. Sometimes there is a possibility that something add-on can come in also. So there should be a greater than. If it is not equal to, then a generalized symbol is not equal to. So the first thing which would have come is like from observation, either equal to or not equal to. How much, then the act of measuring comes in and say by how much it is not equal to, by how much it is less or by how much it is more. So that is when all these number systems come into play, which gives much more clarity for us. Having addressed this, now we started with numbers. We introduced what is called as natural numbers, which is just counting. And the beauty is, the simplest beautiful thing is everything has an interval of 1. Increase in 1, so that things get very, very simple. Now, after the natural or counting numbers, now let's try to see what is the meaning of whole numbers. If I also include the 0 to this set of counting numbers, this is called as whole number, where I can say nothing also, and I can say there is some countable material also there. So the next topic would be, what are integers then?